Alright, so this lesson, exercise 60, we're going to talk about quadrilaterals. So firstly, quadrilaterals are four-sided shapes, okay, four-sided polygons. All quadrilaterals have the same angle sum, and it's all equals to 360. So let's just start with some like a random quadrilaterals, like 1, 2, 3, 4. Oh, a bit longer. So we've got four-sided shapes here, okay? And then I don't think that it's just some, irregular quadrilaterals. There's no special properties about it. If we just divide these quadrilaterals into two, in this way, or if we can divide a quadrilateral that way there, we should be able to see that we end up with like two triangles, as you can see. All right, now from the previous lesson, if we label this angle as angle A, B, C, the angle sum of this triangle is equal to 360 degrees. Oh, is equal to 180 degrees. Oops. And then that's another triangle up here, all right, if you think about it, right? So this is the first triangle I have here. Okay. First triangle I have here. And this is the second triangle. And these two triangles combine together, and if you think about it previously, we know the angle sum of triangle is equal to 180 degrees. So the angle sum here of this triangle is also equals to 180 degrees. So if we combine them together, the angle sum of a quadrilateral is equal to 360 degrees. It's always equal to 360 degrees. That's it, D, E, and F. They're always equal to 360 degrees, just because you can divide a quadrilateral always into, two triangles. And that's what happened. That's the first property of a quadrilateral, so a very important one. Now, once you know the quadrilaterals are, the first special properties is all four angles combined is equal to 360. Then we need to sort of classify the quadrilaterals. There are two different sort of main classifications. Quadrilaterals can be convex or concave. All right, in this case, convex or non-convex. So we can divide the quadrilaterals into two sort of main groups, and then we only sort of focus a bit more on the convex quadrilaterals. Okay, so what is a convex quadrilateral? Now, a convex quadrilateral means all interior angles are less than 180 degrees. So this is the one. All right, so all angles inside, like this one here, all the interior angles are less than 180 degrees. You're not going to see an angle inside is more than 180 degrees. And that's what it's called, convex quadrilaterals. So all interior angles less than 180. Another way to sort of identify or if that quadrilateral is convex or concave or non-convex is if you look at the angle or the vertices, all right, each of the vertices point towards outside, okay? And then a final way to actually look at it is if you draw a diagonals, right, draw both diagonals of a convex quadrilateral, so always line it inside the figure, all right, or inside the shape. So if you draw the first diagonal, that's inside the shape. You draw the second diagonal, that's also inside the shape. All right, so that's a convex quadrilateral. Now, for a non-convex quadrilateral, all right, then you're gonna have something like an angle that's going inside. All right, so I'm going to draw a diagram this way. 1, 2, 3, 4. Okay, so this is still four-sided shape, all right? So that means we still can call this as a quadrilateral. However, as you can see here, one of the angle is more than 180 degrees. Look at this angle here. This angle here is actually pointing towards inside, okay? It's not pointing out, it's pointing inside. And then this angle here, we have one reflex angle, okay? Or one reflex interior angle. So one of the interior angle is actually greater than 180 degrees. But obviously it's less than less than 27 greater than 180 degrees, but less than 360 degrees. Okay, so it's one reflex angle inside, and then if we try to draw the diagonals, one of the diagonals actually lines outside of the figure. So that's the reason why we can also classify as this is the non-convex quadrilaterals. All right, so that's the first thing you need to know. Next, we need to know about the special quadrilaterals. All right, we need to know about the properties. In the exercise, there's a table that you need to complete. You basically need to say yes or no for the certain property that applies to certain quadrilaterals. All right, so there are some special quadrilaterals. I think from year 7, you actually learn all those special quadrilaterals. This is just a little revision here, so you need to remember all of the properties, and then it's very important that you know the difference between, like for example, a square and a rectangle, or be able to answer those questions. Is square and a rectangle, or is a rectangle a square? All right, question like those. All right, so I'm just going to sort of like draw a summary map, all right, for you to actually understand what's going on. So if we have any quadrilaterals, for example, this is just a general quadrilateral. There is no special property at all. All right, this is just general quadrilateral. Now, if that quadrilateral have one pair of parallel sides, okay, just one pair of parallel sides, then we can have a shape that's called trapezium. All right, just one pair of parallel sides, and then that becomes trapezium. All right. If we have two pairs of parallel sides, so that becomes a bit famous, right? It's called a parallelogram. However, with parallelogram, we do have other properties that you need to know as well. So we've got two pairs of parallel lines. So that's the first one, and that's the second one. Now, for a parallelogram, well, there's quite a lot of information that you need to know. Firstly, opposite sides are parallel to each other, and of course, they are also equal to each other. Secondly, the opposite angles are also equal to each other as well. So these angles is equal to that. And then lastly, you can have diagonals, bisect each other for a parallelogram. So the diagonals actually bisect each other. They are equal to each other. All right, so these are the very important information that you need to know. So, bisect each other, like those are equal, okay? Those are equal. Okay, so these two are equal to each other, and these two are equal to each other. All right, now these two sides are not necessarily equal to each other for just a parallelogram. For other shapes, probably will, but not for a parallelogram. All right, then we have another special one, which is sort of like so different to the other shapes. Is one you have, there is no parallel sides. However, there's only one pair of opposite angles are equal to each other, and adjacent sides are equal to each other, and it's actually called a kite. Okay, so what happened with a kite is we have these two angles are actually equal to each other, not the other two. So obviously the angle here is here, and they are not equal to each other. And then another important information about a kite is the diagonal. They are perpendicular to each other, 90 degrees, and then one diagonal bisects the other. All right, so these two sides are actually equal to each other. All right, and then we also notice that from the diagram, you can see that adjacent sides are equal. Adjacent sides, which is the sides next to it, are equal to each other. All right, so from here, we can sort of like, from a parallelogram perspective, if one of the angle of a parallelogram is 90 degrees, for example, here, if one of the angles is 90 degrees, and then that's a parallelogram, and then you can make all four angles 90 degrees. All right, so that becomes a rectangle. Okay, I'm just using different color. All right, so now we can have a rectangle. So a rectangle is still a parallelogram. All right, a rectangle is a special type of parallelogram where there's one additional, very important information about all four angles on 90 degrees. It shares all the properties, okay? So as you can see here, it shares the properties like the opposite sides are equal to each other. The diagonals are actually equal to each other as well, and also bisect. All right, so the diagonals are equal and bisect, which means this time everything are equal. All right, and obviously it shares the property of the parallelogram, so therefore the opposite sides are parallel to each other. So you have two pairs of parallel sides, so everything here, like still remain the same. That is a special type of a parallelogram. All right, then another special type of parallelogram is actually a rhombus. So with a rhombus, it shares some properties between a parallelogram and a kite. Okay. Sometimes people just call a rhombus as like a diamond, which I really don't like. A rhombus is a shape where all four sides are equal to each other. It's pretty hard to draw a shape where all four sides are equal. All four sides are equal to each other. All right, and it's called a rhombus, and there's a special property as well. So all sides are equal, and obviously it shares the parallelogram properties. The diagonals bisect at 90 degrees as well. It shares the property of kite. So it does have some property from the kite and some property from the parallelogram. Okay. Obviously, if it's shared the property of a parallelogram, then the opposite angles must be equal to each other. The opposite sides must be parallel to each other. All these kind of special, not so special anymore, but that's still a quite, I would say, special property about rhombus. But to separate between rhombus and parallelogram, well, the most important thing is for a parallelogram, sides are not equal to each other. Only the opposite sides are equal to each other. All right. However, the rhombus, all four sides are equal. All right. So that's the main difference. And also, the diagonals does not bisect at 90 degrees. However, for a rhombus, the diagonal bisects at 90 degrees. All right. What else we have? All right. Now, if we combine the rhombus and the rectangles, so we'll sort of like combine the property of the rhombus and the rectangles, we end up with a very, very special shape, and that's called a square. All right. Now, square shares so many properties. Okay, a square is a rhombus. A square is a rectangle. A square is a parallelogram. A square is a quadrilateral. A square, you can even call a square as a trapezium because it has a one pair of parallel sides. Sometimes people even call a square as a kite because adjacent sides are equal. It shares the property of a kite. So a square is a really special shape. All right, there's so many property that shares with other shapes. Okay, so that makes squares so unique. All right, feel like this is something that I don't really need to mention that much. All right, for the square, you guys know the properties and everything. So these are just a little revision that you need to know for the relationship between those shapes here. There's one exercise questions where they give you a very big table where it provides you all the properties, and you need to make sure that you know which property applies to which shape. Okay, so that's very important for you to understand here. All right, now we're going to just see some questions. What are sorts of questions that you're going to see from this exercise? So the type of question you're going to see it's like I'm choosing example question 3 from the textbook. So the question 3, they ask you to find the missing prenumerals, okay? And they provide you the shape, but I don't think that actually tells you what sort of quadrilateral is, all right? They just give you the marks on the quadrilateral, and then they give you everything that you need. And then they ask you to find out what's A, what's B. Okay, so what's the angle A and what's the angle B? Now, in order for us to solve this question, firstly, we need to identify, hey, that is a parallelogram. So if we know this is a parallelogram, then we know that B is equal to 76 degrees because the opposite angles are equal. All right, opposite angles are equal in a parallelogram. All right, so once we know B is equal to 76, how do we find A? Well, there's two ways you can find A. This is actually parallel sides, so which means these two angles are co-interior angles. So if these two angles are co-interior angles, when they add together, it should equals to 180 degrees. So therefore, that's, A plus 76 is equal to 180 degrees. So angle A is equal to 180 minus 76. That becomes 104 degrees. That's one way you can do it. We are using the co-interior angles. Okay, that property are supplementary. Unparallelized. You can use this method if you want, all right? There's another alternate way to solve for A. We know that, these two angles here are equal to each other, and also these two angles are equal because they're opposite to each other. So therefore, we also know the property of a quadrilateral is, the angle sum of the quadrilateral is equal to 360 degrees. So therefore, we can do something like 76 plus A is equal to 360. So you end up with 2A is equal to 360 minus 76 minus 76. So 2A is equal to 208 after you do the calculation, and A is equal to 104. That's another way you can do it, by using the property of angle sum of quadrilaterals is equal to 360. All right, angle sum of quadrilateral. All right. So you can use them like multiple different ways to solve this question here. All right. Okay, so that's question 3. Let's move on. Let's try maybe a few other questions. I'll do question 6. Question 6, let's do question 6C. Looks pretty good. That question here. Just draw a diagram. It's not good enough. Okay, that's better. All right, so here's the diagram. If you've got an angle here 74 degrees, that's 22. Here is A, which you don't know, and that angle here is equal to 17. All right, so how do we do this one here? Well, firstly, if you want to find the angle here, which is an angle that's outside, I would suggest you to think about how do you find an angle that's inside, and then we can use 360 to minus. So I'm thinking about finding this angle instead. Let's just call this angle B here. Now, once you know this information, all right, then we also need to find out what is the angle here equals to. Because think about this. This is still a quadrilateral. Oops. This is still a quadrilateral. It's a concave quadrilateral here. It's a non-convex quadrilaterals here, which means, there's an angle that's towards inside. But still, that's fine. The angle sum of a quadrilateral is still 360. So therefore, this angle is equal to 180 minus 74. So that's something that you need to know first. All right? Okay, so we've got an angle that's 180 minus 74. That is... I should know how to do this one without using my calculator. That's 106. And then we can plus all the angles that we know. All right, so we know this angle 106. We know that's 17. We know that's 22. So we should be able to find out what's B equals to. All right, let's try that. So 106 plus 17 plus angle B plus 22 degrees is equal to 360 degrees. So therefore, angle B is equal to 360, subtract everything we have, which is 215 here. So once we know angle B is 215, all right, the angle A is much easier to solve, all right? Just use the same color. Angle A is 360, as you can see, revolution. And then that's entire 360 is removed. All right, we're removing this part of the angle, which is 215. So we're minus 215. And we should be able to get the answer. So that's 145 degrees for the angle E. All right, so that's again question 6A from the textbook. So this is again a I would say very easy. I'd like to do one last question, all right, it's question 7. This question is something a bit like an algebra related. So it's like you have a quadrilateral, so question 7C. You are provided with a quadrilateral. You don't know anything about this, the side, no idea. I'm not drawing a nice diagram. Okay, so you got a quadrilateral like this. They provide you everything you need, like that's 4x, that's x, that's 2x, and here's 3x. So it's all in terms of x. Now the question says, use your algebra skills to find what is the value of x. Well, you know the property of a quadrilateral is 360, right? The angle sum is 360. So therefore, if you add all the angles together and making them equal to 360 degrees, you should be able to solve a very simple very simple algebra equations here. So that's 7x plus should be 10x here. Is that 10? Let's have a look. Yeah, that's 10x. So it's 10x is 360 degrees. So x is equal to 36 degrees. Once you have x equal to 36 degrees, you should be able to find out every single angle by times 36 by 1, 2, 3, and 4. All right, that's all you need to understand from this exercise. It's a pretty simple exercise. I still feel like it's very important that you guys need to know all the properties of different special quadrilaterals. This is extremely important. Eventually, that's in the senior schools, you are going to apply those properties to solve certain questions later on as well. So please make sure that you remember the properties. All right, thanks for watching.